Hello, my name is Marchessault. Recently, OSHA adopted rules and regulations associated with crystalline silica. Silica is part of many things that we do on a day-to-day basis. If we cut, grind, drill, bore, jackhammer into concrete, pavement, rocks, or other types of products that create a plume of dust, we are subjected to the silica regulations. Silica is present in many materials including rock, concrete, bricks, and pavement. And if we use tools that create a plume of dust, we are subjected to serious health hazards. Please take the information you're about to hear very seriously for your health and for the benefit of your families.
All right, so this is the OSHA Silica standard for electric utility workers. The program is designed for workers that will do incidental type of work, including drilling and concrete work, boring holes, cutting from time to time, maybe into pavement or bricks, and those kinds of things. So the objectives of today, hopefully by the end of the session, you will understand and we'll be able to define the silica standard. You'll be able to understand what silica is and understand where it's found, and also describe what the health hazards are related to exposure to silica. And then we'll talk about, of course, and you'll be able to hopefully understand fully how to eliminate the hazard through engineering methods. The scope, it applies to all exposures of respirable crystalline silica, except where employees' exposure will stay below the OSHA action level, which is 25 milligrams per cubic meter, and it's much lower than it used to be. So this is a very small amount of exposure, and we'll talk about that a little bit. When you look at the chart down below, just running a vacuum, let me just pull up the pen. Running the vacuum is 0.75% of that 25 milligrams per kilogram. So that is going to be, that would be like with a HEPA filter. So that means you're almost at the level that you have an exposure by vacuuming up sand. So you have to make sure you have a HEPA filter that is going to handle the silica to keep that level down as much as possible. When you look at using a equipment or dry sweeping and things like that, or handling a vacuum bag that's full, that is way up here at 8 times the level of what the permissible exposure limit is over a time-weighted average of 8 hours. So that's means you can be taking this bag off of with silica in it off of this vacuum cleaner, and you're going to have an overexposure for that. So that process in itself may require respiratory protection. So that's just something to think about. The commonly involved materials include sand, concrete, mortar, blocks, stone. So if you're doing rock drilling, things like that. The grout, stucco, and those things, color hardener, are generally going to be more to the construction industry rather than the utility industry, but certainly the exposures for everything else are included. So what is silica? So it's also called free silica, and it comes from quartz primarily. So sand is pretty much mostly quartz, and sand itself, the size of sand is much larger than the silica that we're talking about where it's a hazard. This would be more airborne in a dust level. So this kind of gives you an idea of the size of this. So a respirable dust is less than 10 microns. If you look at the photo, this grain of salt is 60 microns. So it's 6 times what this respirable dust is. So it's significant. It's 100 times smaller than beach sand. Beach sand typically doesn't rise in the air and cause a plume of dust. So it's very small, and it causes some serious problems. Most of the 59% of silica is basically in rocks, or 95% of it is in known rocks. The products or the stones and the things that you find this: abrasives, coal dust, concrete, dirt, filter aids, graphite, natural mineral products, paints, pavement, plastic fillers, polishing compounds, um, Portland cement. I don't know why Portland cement, but most concrete has it. Sand, slag, soapstone, soil. So all these things have silica, and the big thing, it's always there, it's always present, but as long as you can keep it from becoming airborne, then there's no exposure that you have to worry about. So this is the big problem, creating dust. And whether you're cutting into concrete or bricks or stone or no matter what it is, as long as you keep the dust down. And what we're trying to do is eliminate the dust so we don't have to worry about the respirators. And that's, we'll talk about that in a bit. Silicosis is the worst of the problems. I mean, obviously lung cancer is an issue, but silicosis it affects people more quickly with exposure. It's incurable lung disease that leads to disability or death. So it gets into some of the details of what happens here, but you can see in the photo it just clogs up your lungs with silica, and therefore you just have a hard time breathing. So you have shortness of breath, you have a dry cough, you're wheezing, you end up having weakness until you finally pass away from this terrible disease. Lung cancer, so it's also known as a human carcinogen. It can cause bronchitis and emphysema, tuberculosis. So they're 3 to 30 times more likely to develop pulmonary tuberculosis with these exposures. So that's important. The permissible exposure limit level is 50 milligrams per cubic meter. The action level is 25. So down in the picture, obviously, there's a way more of an exposure. You can see that this respirable silica dust pile is your permissible exposure limit over an 8-hour period. So that next to a penny is very small amount of an exposure, and then you put that up in the air, and that's your permissible exposure limit. So they've dropped this down significantly. To determine the exposure, first you look at the task and try to control. So you're going to go to this table 1. We're going to go through that in a minute. And that's going to be your primary source of safe work practices, and that's going to be the table that will be in your safety manual. So we're going to take a look at that in a second. So we want to do this control exposure assessment, and that includes air monitoring and objective data, including a written. This completion of this exposure assessment is basically when you don't do some of these other things. If you have an exposure that is not engineered out by water or vacuuming, then you need to do this exposure control plan. What we're going to try to do is not have to do this by making sure we have the right equipment to limit the exposure where we don't have to do all these things. Because if we do it, we have to have an exposure control plan. We have to designate a competent person. We have to provide medical surveillance, training for the silica and respirator use, and record keeping requirements for all of this. So it becomes kind of daunting for when you have a lot of people. Electrical maintenance and power plants already do the respirator training and are required to do that, but we're going to try to keep everybody away from having to do that by doing the engineering methods. So to determine the applicability of the standard, first off, what material are used? Are you drilling or jackhammering or boring or doing anything into concrete or rock or bricks that could cause this? And then what tasks are completed? Are you sandblasting? Are what other kinds of things do you do? Does the task or equipment always comply with the listed engineering controls and work practices control method listed on the table? And that's where we want to make sure that if we don't have the right tools to do the work and minimize the amount of silica exposure, then we need to get those tools. Are the task or equipment modified as necessary to comply with the table? If no, the air monitoring is required, and if in compliance with the controls listed on the table, then you're all set. Can you identify the tasks performed that are not included on the table? So those would maybe require air monitoring so that you actually know what the levels are, and then talk about existing representative objective data or combine with air monitoring data to determine what kind of respiratory protection is needed for that particular job, which again, we're going to try to stay away from. So here's the table. So on the left-hand side, we have the exposure levels, and that will include handheld masonry power saws, vehicle-mounted drilling rigs for rock or concrete, and we don't really have a lot for concrete. That's mostly going to be related to construction, but you may be exposed to some rock drilling rigs where contractors are hired to do some install some rock anchors and things like that, where you may be working in the vicinity. So the contractors have to follow this to make sure you stay out of a plume of dust as well. Handheld impact rotary hammer drills, jackhammers, chipping tools, handheld grinders, things like that. Sometimes you may find more in the plants and possibly substations, but certainly with vaults, you could get into that kind of stuff. So the second column will talk about the type of work that you're going to be doing with these tools. So use the saw equipped or the methods to control, I'm sorry. So you're going to use the saw equipped with the integrated water delivery system that continuously feeds water to the blade, and operate and maintain tools in accordance with the manufacturer's instructions to minimize the dust. If you do that, then the next column applies. So do you have to have respiratory protection? No, as long as you have that engineering method in place. For the drills, if you're drilling equipment, if it's outdoors, you don't need it as long as you're using the water and you're minimizing the dust emissions. If it's indoor and enclosed, then you do. You have to have an assigned protection factor, which is related to the type of respirator that you're using. And that would be like an N95 disposable respirator. That's a fit testable respirator. It's like a dust mask that has a seal on it. And so those are available and have been available for power plant and substation work, but is not readily available necessarily or required prior to now for line work type of drilling. As you go down the line, it's the same kind of thing. It's either going to be using a water flow method or using a high efficiency filter, a HEPA filter vacuum when you're cleaning the holes. So one or the other is going to be the process for making sure that you don't have to use a respirator and making sure you have no exposure to silica. Okay, so this table A, if you follow these control measures, pay attention to the duration of time and the task performed, because your exposure limit is over an 8-hour period. So it's not, it's not like, oh, you've got an exposure to 25 milligrams per cubic meter, and then you need to have a respirator right away. Well, you do, but it's 25 over, or I'm sorry, 50 is the limit. 25 is where the plan comes into play. So it's a very, very small exposure that causes you to enact these controls. Make sure you pay close attention to indoor and closed areas, and you exhaust that dust as much as you possibly can. So you'll probably want to do a combination of vacuuming and dust exhaust for that area. Just that would be a local exhaust. Rather than blowing in dust into the enclosed area like a vault, you would probably exhaust it from that area. So it would be a very targeted if you're doing that kind of work, as well as using the proper tool that will collect the dust or wet it down anyways. Pay attention to water flow rates. You want to make sure that you go by the manufacturer recommendations as far as the rates of water that are applied to the tool that you're using. And then or assess and limit the exposure of employees using the alternate exposure control method. So there's the two ways of doing it. If you go back to the table, this would be the method that you want to try to use as much as you possibly can to limit the exposure. Some of the descriptions of the written control plan. So the control plan has to include the task created by the exposure, and so that would list the various things that are done by the utility workers, specific engineering controls, and respiratory protection. So the written program, basically there's a section in the safety manual that will talk about, it'll have the table, but it'll talk about the requirements to make sure that respirable dust, silica dust, is minimized by the engineering methods that we talked about. But there is reference to the respiratory protection standard as well. And the respiratory protection standard has a whole lot of requirements associated with it as well. So we'll talk about those coming up in a second. Housekeeping measures and just sweeping. If you're sweeping in an enclosed areas, that could put you over the exposure limit. And then procedures to restrict access to the work area, where there are people that are working in the area that are not necessarily working on the job that you're working on. And then you review the whole process annually to make sure it's working properly. So OSHA expects routine observations of dust-generated tasks made by the competent person, and I outlined what competent person means. So a competent person is capable of identifying existing and foreseeable silica hazards in the workplace and who has the authorization to take corrective action and make frequent and regular inspections of job sites, materials, and equipment to implement the control program. So if they find that there's increases in visible dust, they are to take prompt corrective action. Shut the job down, find out why there's dust. Is the vacuum or the water not sufficient? So it's not just, okay, well, yep, there was dust, and I guess we just have to do something about it later. No, you have to shut the job down immediately. The control options, as we talked about, so you can substitute the type of work that you're doing to prevent the dust from happening to begin with. You can use water suppression. You can capture, contain it with exhaust and exhaust the dust, so the kind of a combination. Or you can go to respiratory protection. So protection is like the last level. You want to engineer it out or substitute something to try to eliminate the hazard to begin with. Rather than using respiratory protection. And then try to minimize the number of employees exposed. So wherever the drilling or the boring or whatever's being done is happening, make sure that there's minimal people in that area. OSHA has required that the use of an integrated water supply system supplied by the equipment manufacturer for several pieces of equipment on Table 1. So the purpose, they're more likely to control dust emissions efficiently or effectively by applying water at the dust generating site and less likely to interfere with other tool components or safety devices. But it's not intended to prohibit use of other dust suppression methods, meaning vacuum and things like that. So you got to conduct this exposure assessment and comply with the permissible exposure limits required by this paragraph D, which is part of the OSHA standard. So you'll see there's water supplying this tool to prevent this from becoming and actually creating dust. And down at the bottom, it just shows, you may have to have a significant water supply to provide enough. If you're doing a lot of cutting and a lot of work, it may take a lot of water to suppress that. And that may be like rock drilling for pole sets and things like that. So the dust collection system, they're requiring the use of commercially available dust collection systems. There's all kinds of tools out there that provide the dust collection that you need. That would be connected up to a HEPA filter vacuum cleaner. You can go to the manufacturer and get training and tools. Go to YouTube and look at videos and see a whole host of different kind of videos to see what kind of tools are out there. So you can see some boring and drilling and jackhammering tools that all have vacuum systems applied to them. So some of the control takeaways. So employees must be able to demonstrate proper use of tools. So that's just like anything else. We have to know the construction and operation and what we're working with, as well as the safety related work practices. And then we have to be able to plan appropriately for disposal of the dust. So when we're cleaning up wet methods, that's a pretty safe way of doing it because you're dealing with wet product that won't create dust. But cleaning from a vacuum system, that's a whole different ballgame because now you have to deal with the dust as you're cleaning out the vacuum system. So you may need to wear a respirator for that. So if you can do work methods to prevent the dust from that process, then you can eliminate the need for going into the respirator program. So know what to do if intended controls are not working or available. And that's not the mask that this person is wearing. You would need to wear the proper dust mask. These are some housekeeping issues. No dry brushing or dry sweeping unless wet sweeping or HEPA vacuum is infeasible. You got to be able to demonstrate why it's infeasible. Then you'd have to wear respiration protection for doing that process. No cleaning of surfaces or clothing with compressed air. So there's a limit of 30 pounds on the per square inch on the air supply for compressed air, but even that is not good when there's dust that could be airbound that could cause you to exceed the exposure limit for silica. So it's required when cleaning could contribute to the employee's exposure to silica, and then cleaning up particles from high energy type task, not intended to apply to cleaning up ordinary soil or large debris. Okay, so the silica requirements and hazards have to be included in HAZCOM program. So there needs to be a safety data sheet for silica, and any kind of containers with silica must be labeled. So that means if you've done a job where you've done rock drilling or boring and things like that, where you've collected the dust in a vacuum cleaner, that particular dust needs to go into a container that is labeled with this hazardous waste label. So it's going to have this kind of a symbol, and it will say silica dust on that. So you need to look at the SDS, the safety data sheet, to see what the label needs to say. And so it'll say the health hazard, cancer, lung effects, immune system effects, kidney effects associated with silica. And then also you need to determine what the tasks are that you might be exposed to. And then what are your controls? And we already talked about most of this and the contents of the silica standard. And the purpose of the description of the medical surveillance program we're going to get into in a second, with the which is associated with the respirator standard. And then copies of the regulations. You can go to www.osha.gov. That's a requirement for the standard, that everybody knows where to get the standard if you want to see the standard. Okay, so employees exposed to silica is required to wear a respirator before the employee starts doing the work. And the employee, so this is if you don't have some other means of getting rid of the silica, and you have to go with the respirator. So you've got to start before you start working. So the employer must receive documentation that the employee is medically fit to wear the respirator. So that means you have to go through a questionnaire with a physician or have a physical, which is usually the physician will state that you need a physical if you smoke or have other reasons for having a physical. And so that's the must be fit for respirator tests, including an N95 or dust mask. And also you can't have a beard to wear these. So you have to shave before you do rock drilling if you're not going to take care of the respirable level. So down to a low level, meaning vacuuming or wetting down. The employee must receive respiratory protection training before you start and must receive training on the hazards of working with silica, including a HAZCOM and the silica exposure plan. And then before day 30, conduct an initial medical surveillance exam to comply with the silica standard, and then repeat medical surveillance every 3 years. So the standard for fit testing requires an annual fit test. So you would have to do that. This is a tight fitting N95 mask, negative pressure for use only for particles of dust, and is not used for oil type stuff. So this is the APF of 10 that we talked about before. If you had a higher exposure, you'd have to go to a higher level respirator. So the protection training provides for selecting appropriate respirators, and this is just a summary of what you'd have to go through if you didn't do the wetting down or the vacuuming. So what we're trying to do is to keep a lot of people out of this standard, even though there are some people that have to go through this process. So you got to go through procedures for selecting the appropriate respirators, have medical evaluations for the respirator users, do fit tests on an annual basis for the respirators, and that's usually used with Bitrix or banana oil or something like that to make sure that you know that it's actually working properly. And procedures for proper routine and emergency use respirators. Cleaning, storing, inspecting, repairing, and maintenance. Generally, you're going to have disposable N95, so there's going to be minimal storing, cleaning, and inspecting, that kind of thing, and repairing and maintenance. So there's going to be minimal. It'll just be stored in a package before you use it. Make sure adequate quality, quantity, and the flow of breathing air. So with the N95s, that works well for this kind of exposure. Respiratory hazards to what the employee is exposed. So we're talking about that now. And how to wear, use, and care for the respirators. And that's part of the fit testing and training. So voluntary use, if you're going to do voluntary use where you want to wear one of these, even though you don't have an exposure because you've wet it down and you have vacuuming, that's okay to do that. But you do have to read Appendix D for this to make sure that it's worked properly, and it still goes through the fit testing process. Anyways, so this mask is not an N95, and you can see it says is not a respirator. It does not meet NIOSH specifications, not provide lung protection. Using this mask for sandblasting around asbestos, sand, silica dust, grain dust, blah blah blah. It's not for proper use, and therefore should not be used even for voluntary use. Okay, so I'm going to just go through this Appendix D and read through it, because it's one of those things that if you do it for voluntary use, you have to have read or heard this section. So respirators are an effective method of protection against designated hazards when properly selected and worn. Respirator use is encouraged even when exposures are below the exposure limit to provide an additional level of comfort and protection for workers. However, if a respirator is used improperly or not kept clean, the respirator itself can become a hazard to the workers. Sometimes workers may wear respirators to avoid exposure to hazards, even if the amount of hazardous substances does not exceed the limit set by the OSHA standards. If your employer provides respirators for your voluntary use, or if you provide your own respirator, you need to take certain precautions to be sure that the respirator itself does not present a hazard. So you have to read and heed all the instructions provided by the manufacturer on use, maintenance, cleaning, care, and warnings regarding the respirator limitations. Choose a respirator certified for the use to protect against the contaminant of concern. NIOSH, the National Institute for Occupational Health of the United Department Health and Services, certifies respirators. A label or statement of certification should appear on the respirator packaging. It'll tell you if the respirator is designed and how much it will protect you. So that's the requirements for the Appendix D so far. So now, do not wear your respirator in atmospheres containing contaminants for which your respirator is not designed to protect. For example, a respirator designed to filter dust particles will not protect against gases, vapors, or very small solid particles, or fumes or smoke. Keep track of your respirator so you don't mistakenly use somebody else's respirator. So those are the standards, Appendix D, and that's the part that you're required to hear or see before using that. So if we look at this, we've got a little bit of a problem here. So this is more of a dust mask, and it's not. It may be an N95, but it's not. It's not properly fit. It's not used properly. The strap that you're seeing there should be on the back of the person's neck. So obviously that would not even need to be used if they had the proper tool and they wet that down. So this is just a little bit on air monitoring. So if you do have an exposure to dust and you do have to measure that dust, this is a method of sampling, and then basically the samples will tell you what the exposure level is, and then therefore what level of respirator you need to have. And that's in the case where you don't wet this down and you don't and you have an exposure. So you must wet the area if then this is where showing respirators required. If you're doing this kind of work, you have to wet the area. If not, respirators required. But do it safely. So this is showing water, but this obviously is the respirator is not required. That's going to help your lungs, but it's not really going to help the rest of your foot a whole lot if that skips out and jumps down onto your foot. Okay, so just to wrap this up, hopefully we have a better understanding of what crystalline silica is. We have an understanding of where it's found, and pretty much anything that's rock related or man-made or natural. Then the health effects can be devastating. Silicosis is terrible, lung disease, tuberculosis. It's serious stuff. And then hopefully we know how to eliminate the hazard by applying water and also vacuuming using a proper HEPA filter, and then emptying the vacuum cleaner in a safe manner to prevent dust.
That concludes our program for crystalline silica. Remember that silica is a serious health hazard and must be taken seriously. Before doing any work on road work or concrete or blocks or bricks, please remember what we've learned today and take protective measures. Be safe out there.